This is AQA A-Level Chemistry and it's a Year 12 topic, Introduction to Organic Chemistry. It's the second video in a series of 3 for this topic, and as always I'm going to recommend that you have a go at each activity as we go through, pausing the video and then review your answers. So we're going to start by looking at naming some organic compounds now, and we're going to limit it in this particular section to alkanes, alkenes, and haloalkanes actually are going to be included. We need to know about the terms functional group and homologous series. And what will happen is we will build some rules here that we will continue to build on as we look at subsequent functional groups in future chapters across Year 12 and Year 13. To begin, have a go at filling in this table for how we name compounds that have a carbon chain of 1, 2, 3, 4, 5 and 6. Now, a lot of this will hopefully be familiar from GCSE. Certainly the first 4 alkanes that you would have learned were methane, ethane, propane and butane. At A-level, we had pentane and hexane as well, but you have got to be absolutely certain about using the correct name in the correct place, or marks can easily get lost. Mnemonics are a great way of dealing with this, and there are many of them out there. A really straightforward one, My Easy Process, best provides help. Okay, now let's take a look at how the naming can get slightly more complicated than we've seen before. What would be the molecular, empirical and skeletal formula for the 2 compounds that we have here? Well, if I start with molecular, they have got 1, 2, 3, 4 carbons, 1, 2, 3, 4 carbons, 4, 8, 10 hydrogens, and 3, 4, 5, 6, 7, 10 hydrogens. They've both got the same molecular formula. And if they've got the same molecular formula, that does mean they've got the same empirical formula. However, if we look at the skeletal formula, where we have got 1, 2, 3 carbon bonds in a row, that goes 1, 2, 3. But on this side, I've got 2 in a row with 1 branching off. So my skeletal formula is different for the other one. And that does mean they're going to have a different name. They are not both butane. So now let's start to take a look at how we're going to name these. On each, highlight the longest unbroken carbon chain. What will the root of each name be? And then let's have a think about how we could change the naming for the one on the right. Well, my longest unbroken chain on the left is 4 and on the right it's 3. That 3 could have gone across and down, could have gone from there and back and down, but it's still 3 in a row. Now that means that my name is going to be based on butane, but this one is going to be based on propane. This one's name actually is butane. I've got nothing else coming off it. But on here, I've got a single carbon in a chain coming off, branching. Now, 1 carbon is methane. We call the side chain a methyl group. So I've got my names now. I have butane and I have methyl propane. Let's take a look at these examples. Skeletal formula have been provided. So what's the root of the name going to be, and how are we going to go on and name them? Work your way through these tasks. And what I can see here is that I've got 1, 2, 3, 4, 5 carbons in a row. 1, 2, 3, 4, 5 carbons in a row. Both of them have got a branch coming off. So I've got 5 carbons in a row in each case. So the root of the name is going to be pentane. Now the branching that's coming off is a single CH3 and a single CH3. As we discussed in the previous example, that means that it's methyl pentane. But we have a problem because these compounds are not identical. So because they're not identical, we need a way of differentiating between this methyl pentane and this methyl pentane. And here's what we do. We number the carbons. I go 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. And then I'm going to number the position of my methyl group. So this one is 2 methyl pentane because the methyl is on the 2nd carbon, but this one is 3 methyl pentane because the methyl is on the 3rd carbon. So have a go at this one. Now, once again, we go through, you can see I've got 1, 2, 3, 4, 5 carbons. That means it's pentane. I've got a methyl coming off. And following the logic that we've done previously, there's a chance you've said 4-methyl pentane. But that is incorrect. It's a very common misconception and one we need to avoid, because we actually don't number the carbon chain from left to right. We number it so the carbon chain will be at the lowest possible position. So I'm numbering it that way. And that means I've drawn 2-methyl pentane. It's identical to the 2-methyl pentane that we've seen here. It's just been flipped over. So 2-methyl pentane is the correct answer. Okay, let's go on and look at some more complicated ones. But first, let's deal with some key information that you should hopefully be bringing from GCSE. What is the definition of a hydrocarbon? So a hydrocarbon is a compound made of carbon and hydrogen. Does not get the mark. We're missing a word. Only. That is absolutely vital in this definition. It contains carbon, it contains hydrogen, it does not contain anything else. It's a compound made of carbon and hydrogen only. I've highlighted it, it's so important. Now let's move on. A lot of information is going to be given to you here. Some of it's going to be relevant to what we're doing now. Some of it is preempting what you will do in future topics and future chapters. So we need to know what functional groups are, and they are reactive groups attached to a carbon chain. It might be an alcohol group, a chloro group. A homologous series is what we call the family of compounds that all contain that functional group. You've met some functional groups already. Here are some examples that you will come across over year 12 and 13. You already know alkanes, alkenes, alcohols, a little bit on aldehydes, ketones, carboxylic acids. Probably not so familiar with haloalkanes, nitriles, amines, etc., but you will become familiar with them all. And this table gives a nice little summary of the ones that you will learn in year 12. We, for the next couple of activities, are going to focus on alkanes, alkenes, and haloalkanes. And I'm going to recommend that you take a look at this table, pause it, get the key information down before you try the tasks that follow. Okay, so let's now have a think about how we're going to answer these. These are haloalkanes. You've been given the skeletal formula. What would its name be and what would its display formula look like? Well, remember the skeletal formula simplifies the CH3s and CH2s. So I've got 1, 2, 3 carbons in a row with a chlorine coming off. I can draw that as a display formula, and that might be the easiest way to approach naming. So that's my display formula drawn out. This carbon has 3 H's around it. This carbon, 2 H's. This carbon, 2 H's and a Cl. And we know that because every carbon will have 4 bonds coming from it. Now my longest carbon chain here is prop. So it's going to be propane at the end of the name. But I need to show that there is a chlorine coming off it. So to do that, I use the prefix chloro. So my name now is chloropropane, all one word. But my chloro could be on the first carbon, it could be on the second carbon. So I need to number it as well. I number my carbons, 1, 2, 3. And that means my name here is 1-chloropropane. So let's try another example. And for this one, we've got 1, 2, 3 carbons in a row. That means that we can draw the display formula, and you can see here that the chloro is on the second carbon this time. Now there are still 3 carbons in a row, so it's propane. There is still a chloro coming off, so it's chloropropane. But this time when I number the carbons, I'm going to go 1, 2, 3. I could easily have gone 1, 2, 3 that way, and it would give me the same outcome, but my name is 2-chloropropane. Another example here. And I'm going to number my I've got 4 carbons, so I'm going to draw my display formula out 4 carbons in a row, fill up with H's, and because it's 4 carbons, that means my name is going to be based around butane, because my easy process, best for butane, if we use the mnemonic. Now the prefix for bromine is bromo, so it's bromobutane. We need to number its location because it could have been on the end, but it happens to be in the middle of a carbon chain. On this one, I'm going to number from right to left because that gives me the lowest possible number for the position of the bromo. If I'd numbered from this side, it would be 3 bromo. That would be incorrect. I've got 2 bromobutane. Let's take a look at another example. This time you're given the display formula, you're going to name it and draw the skeletal formula. Now the skeletal formula here, I can get rid of all of the H's, I just need to show the CC bonds. One of those is a double, so I've got my double and my single carbon-carbon bond. Now there are 3 carbons in a row, which means it's based on prop, but because it's an alkene, it's going to end in -ene. I don't need any numbers here. I've finished it because I have got 3 carbons, but the only propene that can exist is prop 1-ene because it starts at the first carbon, so we don't have to put the number in. Let's now try this one. Again, starting with the skeletal formula, I've got a double, a single bond. That's what I've drawn there. Because it's 4 carbons in a row, it's based on bute. It is an ene, and my ene here starts at the first carbon in the chain when I number. You'll notice I've gone left to right here because that puts the lowest possible number for my double bond. So this one becomes bute 1-ene. Let's try this one. Again, my skeletal formula, I've got a single bond, a double bond, a single bond. I've taken away my H's and we're done. It's 4 in a row, so that tells us that it's bute, and it's an alkene, so it ends in -ene. But if I number my carbons, my double bond starts at the second carbon. That means that this one is bute 2-ene. Couple more questions here for you to try. This contains haloalkanes and alkenes. See what you can do. So in the first one, I'm going to put the carbons in the location that they should be so I can see it, and there are 4 carbons. So my name is bute. Now, you're also going to have to learn about priorities of functional groups, and alkenes have a higher priority than haloalkanes. That means we number to give the alkene the lowest possible number. And that gives me bute 1-ene, because I'm starting carbon 1, 2, 3, 4. Now that means that my chlorine is on the 4th carbon, so I get 4-chlorobute-1-ene. You can see it's starting to get a little more complex. Next example, I've got 1, 2, 3, 4 carbons in a row. That means my name is based on bute. My double bond starts at the end of a carbon chain, so it's going to be bute 1-ene. And in this case, I have got a chloro coming off on the 1st, 2nd, 3rd carbon. So 3-chlorobute-1-ene. More examples for you. Now, different haloalkanes don't have greater priority over each other, so we number to give the lowest numbers possible overall. So on this one, I'm going to go 1, 2, 3, because that puts a chloro on the 1st carbon and a bromo on the 2nd. If I numbered the other way, I would have a bromo on the 2nd and a chloro on the 3rd. So 1, 2 is better than 2, 3. Now, it's propane because of the 3 carbons in a continuous chain. And I have got a bromo on the 2nd position, so that's 2 bromo. And I've got a chloro on the 1st carbon, so that's a 1 chloro. You'll notice I've put them in a particular order. Anything else would be incorrect because any prefixes in your name must be in alphabetical order. Bromo comes before chloro. We don't do 1 and then 2. So the next example, I've got 3 carbons in a row. I have got 2 chloros on the 1st carbon, 1 bromo on the 2nd carbon. I've got 3 carbons in total, so it's propane. Now in this case, remember, bromo comes before chloro, so 2-bromo. I need to number both of the chloros. They're both on the 1, so it's 1, 1. But actually I need something more. Because I've got 2 chloros, I need to represent that by saying dichloropropane. A lot to think about as we start to build these rules. So let's summarise some of those now. First of all, you're going to find the longest unbroken chain, and that's the root of the name. You then identify any side chains. They might be methyl groups, they could be ethyl groups. And if you need to number their position, you do. If the compound is an alkene, you will end the name in "ene" rather than "ane, and you may need to say where that double bond starts. And you need to look for other functional groups, as we have done with halo groups, with halogens. And you've got to use their prefixes, chloro, bromo, iodo, and you need to number them accordingly. And for multiples of the same functional, you are going to show that multiple within the name. So we had dichloro. If there were 3, it would have been tri. If there were 4, it would have been tetra. We will build on all of these rules as we go. Moving on, number your carbons. Oh, so final rule here, number your carbons to give the lowest possible numbers, as we just saw with the halogens, but we also have to focus on the priority of the functional groups. So alkenes are a higher priority than haloalkanes, so we get them the lowest numbers possible as a priority. Again, this will be built on as we revisit each of the functional groups in future topic reviews. Final question on this particular video, quite a long video I know, homologous series research task. There are 4 characteristics of a homologous series. What are they? They have the same general formula, they have similar chemical properties, the trend in physical properties is visible as you increase the chain length, so there is a clear trend, and they differ by a CH2. It's also really important to say here that what makes a homologous series is the functional group it contains. Alcohols are alcohols because they contain the OH alcohol group. Alkenes are alkenes because they contain the C double bond C functional group. That takes us to the end of this video. Thank you for listening. Goodbye.